Hello Cloud Gurus and welcome to this overview of Azure Active Directory. Azure Active Directory, or Azure AD, is the identity and access management solution for users, groups, applications and roles. Some example use cases: logging on to the Azure portal as an administrator, accessing an Office 365 document, and single sign-on to web apps. When we created our Azure account, we set up an Azure Active Directory tenant. Now that Azure AD tenant is the central identity source, which can be used both for Office 365 and also Azure resource subscriptions. And there may well be more than one Azure resource subscription. So for example, it's common to have one for user acceptance testing, another for production, and another for development. It's important to understand Azure AD licenses and features, and it's very likely that this subject will come up in the exam. There are 4 tiers of Azure AD: Free, Basic, Premium P1, and Premium P2. Some services are available across all 4 tiers, for example, user management. However, mobile device management requires a premium level license. Single sign-on to web apps is available across all licenses. However, there's a limit of 10 apps per user in the free and basic tiers. Azure AD Connect provides synchronization to your on-prem Active Directory, and that is available across all 4 tiers. However, Azure AD Connect Health requires a premium license. Conditional access, multi-factor authentication, terms of use, and password protection all require a premium tier. And identity protection and privileged identity management need the top-level Premium P2 license. It's important to note that Azure AD isn't a fully fledged Active Directory domain controller in the cloud. It does include device registration for Windows 10 and mobiles, and the ability to associate a real-world domain name with your Azure AD. Some of the things which it doesn't include are domain join of virtual machines, LDAP and Kerberos protocols, and group policy. So if you do want to domain join an Azure virtual machine and apply group policy, some of your options are to extend your on-premise Active Directory to the cloud, to use self-managed AD domain services on infrastructure as a service virtual machines, or to use the Azure AD domain services, which is Microsoft managed AD/DS on IaaS. So that's all for now. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus and welcome to this lecture on Azure AD users and groups. Users within Azure Active Directory can come from a number of sources. Microsoft accounts, such as the Outlook account which I used to create the Azure account in the first place. Users created directly within Azure AD itself. And guest users from other organizations' Azure ADs. Guest users can be invited via the Azure AD business-to-business feature, and the number of invited users can be up to 5 times the licensed number of Azure Active Directory users. There are 2 types of groups within Azure AD: Security, which relate to permissions, and Office 365, which represent email distribution lists in Exchange Online. Membership types can be assigned or dynamic based on user properties, dynamic based on device properties. However, a group can't be dynamic for both users and devices. And it's worth noting that groups within Azure AD can be nested. There are 2 main types of roles within Azure: Azure AD administrator roles, which relate to permissions within Azure Active Directory itself, and Azure resource roles, or RBAC, role-based access control, which grant permissions to Azure subscriptions and resources. Roles can be assigned directly to a user. They can also be assigned to a group, however, only in the case of Azure resource roles. You can't assign an Azure AD role to a group. Roles can be assigned to app registrations. And role definitions can use the Microsoft built-in roles, and it's also possible to customize your own roles. And finally, it's worth noting that the Microsoft account which you used to create the Azure account in the first place has automatically been assigned a global administrator role from Microsoft. And now it's time for the Azure AD User Lab. Start by creating a user and temporary password. Then create a group and add the user as a member of that new group. Then, in a separate browser or separate private incognito window, log in as that new user and you'll be forced to update your password. Then, try and create another user and check out your default rights within Azure AD. Back in the admin browser, assign the user administrator role to the user, and then, as the new user, log out and log back in. And finally, confirm that you're now able to create another user, now that you have the additional administrative rights within Azure AD. So if you want to take the challenge approach to this lab, please pause the video now, go through these steps, do it yourself, and then compare how you did it with my walkthrough. Otherwise, I'll see you in the Azure portal now. So here I am in the Azure portal. Before we get going, I'm going to select the settings icon and change to my favourite theme, a mixture of dark and light mode. You might prefer one of the others. Next, I'm going to go to Azure Active Directory, Users, and you'll see that Microsoft has automatically put in my Outlook account, which I used to sign up to the Azure account in the first place. And that makes sense, because this is the administrator user, which I'll use to set up the account and subscriptions. I'm now going to take a look at domain names, at Azure Active Directory, custom domain names. And you'll see that Microsoft has automatically created a unique domain name which represents my Azure AD tenant. So what they've done is concatenated the two parts of my email address. So my email address was paulmschwarzenberger@outlook.com. So they've discarded the com and put Paul M. Schwarzenberger together with Outlook to make Paul M. Schwarzenberger Outlook, and then use that as the subdomain for .onmicrosoft.com to create a unique domain for my Azure AD. At this point, if I wished, I could add a custom domain name as well, and I may do that as part of a later lab or demonstration. So I'm going to copy this domain name to the clipboard and then head over to Users. And now I'll create my new user. So my username is Marcia Silva, and her unique username is Marcia at, and then I'll paste in the unique domain which Microsoft generated for me. I'll press create, and you'll see that Microsoft has automatically generated a temporary password for Marcia. So I'll copy that to the clipboard and then press create. So I now have Marcia as a user, and I'll head over to Azure Active Directory and then groups. I'll add a new group. I'll call my group students. I'll leave the description and owner blank. And under members, I'll search for Marcia and add her as a member of this group. So I'll test Marcia's login with a different browser, also in a private incognito window. I'll go as Marcia to the Azure portal and log in. I'll paste in the temporary password that was generated by Microsoft. I'll enter and confirm a new password. So I've logged in as Marcia to the portal. I'll go to Azure Active Directory to look at user rights. And you can see that Marcia isn't allowed to create a new user because that tab is greyed out. So let's take a look at Azure Active Directory groups. Interestingly, she is allowed to create a group, and that is the default behaviour of Azure AD. So now let's go back to the administrator's browser. So as the administrator, I'm going to grant Marcia permissions to add and delete users. So I'll go to Azure Active Directory, Roles and Administrators, and I'll search for a role with the word user in it. I'll select the user administrator role, add assignment, choose Marcia, and add her to the role. So now let's go back to Marcia's login and see if she has more permissions. So Marcia is now going back to Azure AD Users. However, the tab for a new user is still greyed out. So Marcy is going to sign out and log back in, re-enter her password, heading back over to Azure Active Directory and Users. Marcia now has the rights to create a new user. So that concludes the Azure AD User Lab. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus, and welcome to this lecture on Azure AD Apps. Applications within Azure Active Directory can function as a client role, meaning that they consume a resource. They can also function in a resource server role, so exposing an API to clients. And they can act in both the client and resource server role. Authentication and authorization protocols supported by Azure AD include OAuth 2, which also includes OpenID Connect, and SAML version 2, which includes WS Web Services Federation 1.2. The main properties of an app registration within Azure AD are the display name, that's what gets shown in the portal, admin SP in the example of the screenshot, the unique application ID, also known as client ID, the directory ID, or tenant ID, which represents the Azure Active Directory to which the application belongs, and the credential, which may be a client secret or a certificate. By default, all users can register apps. Now, for security reasons, you may well want to disable that. So to do so in the Azure portal, go to Azure AD User Settings, change Users Can Register Applications to No, and press Save. It's important to understand the difference between application objects and service principals within Azure AD, and I've put a link to a good article on this in the resources section for this lecture. An application object in Azure AD is the initial definition of that application. The application ID is generated when the app is created within Azure AD, and this all takes place within app registrations in the Azure portal. A service principal is an instance of an application with rights to an Azure AD tenant. And the service principal is created when an application is given consent to a particular Azure AD tenant. And that could be the Azure AD tenant in which the application is created in the first place, or it could be a completely different one. And all of this takes place within enterprise applications in the Azure portal. If you take a look at the screenshots showing enterprise applications or service principals in my Azure AD, you'll see that some of them, for example the admin SP one at the top, represents an application which I created myself within app registrations and then assigned rights to, so it then appeared under enterprise applications. Others, such as Azure DevOps or Office 365, represent applications which were created by Microsoft, but then assigned rights within my Azure AD tenant. A single app can be granted consent to multiple tenants, and a good example of that is Microsoft, which has its own apps for administration. So if you look at enterprise applications within your Azure AD, you'll see a whole load of apps that Microsoft has to administer your account. You can also obtain apps from third parties through the gallery, which is made available by Microsoft. There are different types of permission scopes and consent for Azure AD apps. Delegated permissions are those where the signed-in user is actually present using the app, and that consent may be granted by the user themselves or an administrator, depending on policy. Application permissions are when no signed-in user is present, and admin consent is required to give that application permission to the Azure AD tenant. And now it's time for the Azure AD App Registration Lab. Step 1 is to start the Azure Cloud Shell, choosing the Bash option. Then use Azure CLI to create an Azure AD group in the context of your logged-in administrator user. Then create an app registration using the portal. Create and record a client secret. Select API permissions, application permissions, Azure Active Directory Graph API, and then choose the permission directory.readwrite.all. Grant consent as an admin user. and return to the Bash Azure Cloud Shell. Use AZ login to connect as the service principal. And finally, in the context of that service principal, create an Azure AD group. So if you want to take the challenge option, then please pause the video now, do this yourself, and when you're finished, compare how you did it with my walkthrough. Otherwise, I'll see you in the Azure portal now. After you've logged into the Azure portal, start by selecting Cloud Shell and choose the Bash option. You'll create storage, and as the storage account is being created, I'm just going to mention that it's really important to become familiar with both Azure CLI and Azure PowerShell in order to be an expert security engineer in Azure. Also, it's very likely that there will be questions or exercises in the exam which require knowledge of both Azure CLI and Azure PowerShell. So your Cloud Shell storage account should now have been created and your Cloud Shell is being initialized. You'll now be ready to use Azure CLI. Start by typing AZ to indicate it's Azure CLI, then AD for Active Directory, group, create, then -- display -name, and call your group help desk, and then give it a mail nickname of help desk as well. Press enter, and you'll see details of your group above. Let's have a look at this in the portal. So head over to Azure Active Directory, Groups, and you'll see the help desk group which you've just created. If your new group hasn't come up in the portal straight away, just wait a little while and then refresh your browser. Your next step is to create an app registration. So go to Azure Active Directory, App Registrations, call your app registration helpdesk-app, and leave the supported account types as only for accounts in this organizational directory, which is the default. Next, select Register. An application or client ID has been generated for your new app. You'll also see your directory or tenant ID. Next, head over to Certificates and Secrets and create a new client secret. Give it a name and leave the expiry as 1 year. Your new client secret has been generated, and this is the only time you'll ever see it within the portal. Copy it to your clipboard and paste it into a text editor. You'll need it later. Next, have a look at your API permissions. By default, your new app has been given permissions to read user profiles. So add a new permission. Select the Azure Active Directory Graph API. That's different, by the way, from the Microsoft Graph API. Choose Application Permissions, Directory, and directory.readwrite.all, which allows the app to read and write data such as users and groups, but it doesn't allow user or group deletion. Add permissions. You'll see an amber warning at the top of the screen. Permissions have changed. Users and or admins will have to consent, even if they have done so previously. So now grant admin consent for the default directory, confirm, and the warning has changed to a green tick. You have successfully granted admin consent for the requested permissions. Return to Cloud Shell. Your next step is to log in within the context of your new service principal. Type AZ, login, -- service-principal, -- username, and go to the overview screen of the app registration. Copy the client or application ID to the clipboard. Paste it into Cloud Shell. -- password. and retrieve the client secret from your text editor. And it's a good idea to put it within quotation marks so that you don't experience issues with special characters. So double quote at the beginning and a double quote at the end. Dash dash tenant. And now you'll need your tenant ID, so you can get it from the overview screen as well. Press enter. Okay, so you'll see a couple of warnings. The first warning in orange says that Cloud Shell is automatically authenticated under the initial account signed in with. Run AZ login only if you need to use a different account. Well, that's fine because the whole purpose of this lab is to log in within the context of an Azure Active Directory service principal. The second warning in red says that no subscriptions were found for this app registration. If this is expected, use allow no subscriptions. Well, in this case, it's exactly what we want to do because we didn't give this app rights to any subscriptions. So, up arrow to repeat the last command and then dash dash allow -no -subscriptions at the end. Press enter. And you've now logged in within the context of your service principal. And you can see that is the case by the fact that the type of login is shown as service principal. So next, you should create a new Active Directory group within the context of your service principal. So use the up arrow a couple of times to retrieve your previous command. Change the name to Helpdesk App so that it doesn't conflict with the Helpdesk group which you've created earlier. Press enter. So that looks great. You've got details of the group. Have a look within the portal at Azure Active Directory groups. And you can see your new Helpdesk App group you've created using your service principal. If for any reason your new group isn't showing in the portal straight away, just pause the video, wait a little while and refresh your browser. So you're not actually able to delete the group using the service principal. You can try that if you like and you'll receive an access denied message, but you can delete it in the portal if you wish to. So that concludes the app registration lab. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus and welcome to this lecture on Azure AD Baseline Protection Policies. Baseline protection policies in Azure AD are predefined, meaning that they can't be optimized or changed. They are available with all Azure AD editions. The baseline policies are require MFA for admins. This requires multi-factor authentication for Azure AD administrator roles, such as Global Administrator, Exchange Administrator, and Helpdesk Administrator. Another baseline policy which can be selected is End User Protection. This protects users by requiring MFA during risky sign-in attempts. Users with leaked credentials are blocked from signing in until they reset their password. Choosing the baseline policy Block Legacy Authentication prevents legacy authentication protocols which don't support multi-factor authentication. Examples of these are the MEL protocols IMAP, POP, and SMTP, but it doesn't block Exchange ActiveSync. The final baseline policy that's available at the moment is Require MFA for Service Management. This requires the use of multi-factor authentication for services using the Azure Resource Manager API, and that includes the Azure Portal, Azure CLI, and Azure PowerShell. It's important to note that baseline policies may have an impact on apps and automation, and that's particularly the case for the fourth of the baseline policies, Require MFA for Service Management. If you have a CI/CD pipeline server using a service principal to deploy to Azure, that isn't going to be able to use multi-factor authentication, so enabling this baseline policy would stop that from working. And now we'll dive straight into the Azure AD Baseline Protection Policy Lab. The first step is to create a new admin user. Now we're going to do this because the Azure Account Portal, that's what you use if you want to buy new licenses or enable pay-as-you-go. That doesn't support MFA, so we're going to create a new admin user for the purpose of this lab and generally to use for the rest of the course. Assign the global administrator role to the new user. Log in as the new admin user. Then, in Azure Portal, select Azure AD Conditional Access. And enable the baseline policy, Require MFA for admins. Log out of Azure and log back into Azure as the new admin user. And then follow the instructions and enroll to use the Microsoft Authenticator app on your phone. If you want to take the challenge approach, then please pause the video now, follow these steps, and when you're finished, you can compare how you did it with my walkthrough. Otherwise, I'll see you in the Azure portal now. You've logged into the Azure portal, so start by creating the new admin user. You can call the user global admin, and the username will be globaladmin at, and then your domain. Press create, show password, and copy. Next, assign the global admin role. Select the global administrator role. Add assignment. Choose your global admin user and add it to the role. You should now log out and log back in as the new user. Log in as the new user, and you'll need to set your password for the first time. And now you're logged in as your new global admin user to the Azure portal. Now go to Azure Active Directory, Conditional Access, and select the baseline policy Require MFA for admins. Choose Use Policy Immediately and press Save. You can test your new policy by logging out and logging back in. Logging back in as the new admin user. You should now get a warning that more information is required. If this doesn't come up straight away, then just pause the video, wait a couple of minutes, maybe have a cup of coffee, come back and try again. Press Next. Choose the mobile app option and receive notifications for verification. Set up. If you haven't already done so, pause the video while you install the Microsoft Authenticator app on your phone. Use the Microsoft Authenticator app to scan the image, adding a work or school account. Your app should be displaying a 6-digit code, so press Next. Your mobile app has been configured for notifications and verification codes. You'll now be asked to respond to the notifications on your device. Once that's successful, just press Done. You've enabled your first baseline protection policy in Microsoft Azure. Well, that concludes the Azure AD Baseline Protection Policy Lab. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus, and welcome to this lecture on setting up an Azure AD Premium trial. Azure AD Premium, P1 or P2, is needed for conditional access, multi-factor authentication, terms of use, password protection, and Azure AD Connect Health. Azure AD Premium P2 is required for identity protection and privileged identity management, and the Azure AD Premium P2 trial is free for 30 days. So let's get on and enable Azure AD Premium P2. In the Azure portal, select Azure AD Security Overview. Select Get a Premium Trial to use this feature. Select Azure AD Premium P2 Free Trial and press Activate. Check to see that the Premium P2 features are now available. And if you wish to continue using these features after 30 days, you'll need to purchase licenses for the number of users required to use these features. So if you'd prefer to follow these steps to enable Azure AD Premium, please pause the video now and go ahead. If you'd like to watch my walkthrough, I'll see you in the Azure portal now. You've logged in to the Azure portal. Go to Azure Active Directory, start a free trial, select Azure AD Premium P2 free trial, and activate. Your Azure AD Premium P2 free trial should now be successfully activated. You can check this out by going to Active Directory, Licenses, and you should have the Azure Active Directory Premium P2 license with no users assigned. If this doesn't come up straight away, don't worry, it may take several minutes, so you can come back later. Going back to Azure Active Directory, take a look at one of the services which require a premium license, for example, MFA. There should now be no warning that you need a new license. So that concludes this short lab on activating the Azure AD Premium trial. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus, and welcome to this lecture on conditional access and MFA. Conditional access in Azure AD is set through conditional access policies. And a conditional access policy states that if a particular event or condition occurs, then take a certain action. So for example, if the user is coming from a particular location from a device which is not compliant, then require a multi-factor authentication, and maybe also require that that user brings their device into compliance before accessing services in Azure. Some of the conditions which can be used within conditional access policies are which cloud applications are being accessed. That could be Azure Portal, or it could be a particular app. Azure AD users and groups. It could, of course, be applied to all users. Sign-in risk, as determined by Azure AD Identity Protection. Network location, determined by IP addresses. The device compliance status, and the client application being used. Some of the actions which can be set within a conditional access policy are to allow access with multi-factor authentication, allow access but only from a compliant device, require acceptance of terms of use, or, of course, deny access completely. Azure AD Conditional Access requires an Azure AD Premium license. Mainly for historical reasons, there are several different product options for Azure AD Multi-Factor Authentication, or MFA. MFA for Azure AD Global Admins and MFA using baseline protection policies are both available for all Azure AD editions. However, they each have a few limitations, namely that there's no configuration possible for the policies, and also the authentication type is limited to the Microsoft Authenticator app with notification. The MFA full version can use the Microsoft Authenticator app, either in notification mode or with a verification code, a hardware token with code, a phone call, or SMS. The full version of MFA requires an Azure AD Premium P1 or P2 license. The Azure AD MFA registration and the self-service password reset features both use the same set of configurations and user interface. In both cases, there's a need to verify the user's identity, and this can be done by a number of different methods. Email, getting the user to enter a mobile app code, a phone call, or security questions. It's best practice that for MFA registration, in other words setting up the MFA in the first place, that a conditional access policy is used to only allow registration from trusted network ranges and compliant devices. So now it's time for the Azure AD Conditional Access Lab. Before you start, ensure that Azure AD Premium is enabled, and also that you've completed the Users and Groups lab. If you haven't, don't worry, just set up a group, and make the user a member of the group. Make sure that your admin user isn't a member of that group. Step 1, as the global admin user, is to remove the user administrator role from Marcia, as she may have been assigned it during the Users and Groups lab. Then, in another browser, log in as Marcia to the Azure portal just to check credentials. Then, back in the global admin user's browser, Go to Google, search for IP address, and that will return your current IP address, or use a site like whatismyip.com. Step 4 is to create a conditional access policy for the students group, stating that if the request is coming from your IP address, then deny access. Step 5 is to test this by logging out as Marcia and attempting to log back in. That should fail. Step 6, back in the global admin's browser, is to change the IP address in the policy to something else. And step 7, as Marcia, is to log in again, which should now be successful. When you do this lab, be careful not to lock yourself out. The admin user must not be a member of the group. If you want to take the challenge approach to this lab, please pause the video now, follow the steps as shown, and when you're finished, you can compare how you did it with my walkthrough. If you'd prefer to follow step by step, or just watch as I go through the lab, then I'll see you in the Azure portal now. You've logged into the Azure portal as your global administrator. Start by removing any roles from your test user, Marcia in my case. Select Directory Role, User Administrator, and remove the assignment. Next, log in as Marcia in a separate browser. Once you have successfully logged in as Marcia, you know her credentials are fine. So return to the global admin browser, open a new tab, and search for IP address in Google. This will bring up your public IP address. Copy it to the clipboard, go back to Conditional Access, Named Locations, New Location. You can call it Office, paste in the IP address, add a /32, and create. Conditional access, new policy, and call the policy Student Policy. Select Users and Groups, choose the Students group, and press Done. At Cloud Apps or Actions, choose All Cloud Apps. Under Conditions, pick Locations, configure Selected Locations, the Office. At Access Controls, block access, enable the policy, and create. Now, it's time to test Marcia's access. As Marcia, sign out, and sign back in. You should see the expected warning for conditional access. You cannot access this right now. Return to your global administrator's browser. Go to Named Locations, Office, and delete the existing IP address. Then add a fictitious one. Return to Marcia's browser. Try again. And now she can access. So that concludes the Azure AD Conditional Access Lab. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus, and welcome to this lecture on Azure AD Password Protection. Passwords are often very easy to guess. Lists of regularly used passwords are available to hackers. The National Cyber Security Centre, that's the UK government body for cybersecurity, recently published the top 100,000 passwords based on compromised credentials. And believe it or not, the top password is 123456, with a total of 23.2 million compromised users having this password. Users with bad passwords can be a particular issue for cloud services, where login is usually accessible from anywhere. Azure AD password protection stops users from creating so-called bad passwords. In other words, passwords which are regularly used and have been seen before. Azure AD password protection requires an Azure AD Premium license. One of the features of Azure AD password protection is Smart Lockout, which locks out bad actors trying to guess user passwords. You can set the lockout threshold and the lockout duration in seconds. The other principal feature of Azure AD password protection is banned passwords. Microsoft maintains their own list of predictable passwords which are not allowed, and you can add your own custom list of up to 1,000 banned passwords. The scope of Azure AD password protection is of course Azure AD, but optionally you can also use this service for your on-premise Active Directory. If you do want to apply Azure AD password protection for your on-premise AD, you'll need to install a couple of components, the Azure AD Password Protection Domain Controller Agent and the Azure AD Password Protection Proxy Service Agent. And now it's time for the Azure AD Password Protection Lab. Start by taking a look at the Azure AD Password Protection settings. Then create a new Azure AD user. Record the temporary password. In a private or incognito browser, log in to the Azure portal as that new user. The new user will be prompted to change their password. Enter the existing password, and then enter a deliberately bad password which does need to meet the complexity requirements. At least 3 of uppercase, lowercase, number, and special character. Some examples. And I'm sure that none of you would ever choose a password like one of these. You should see a message similar to the screenshot. We've seen that password too many times before. Choose something that is more difficult to guess. Enter a password which isn't blocked. And when I did this, it did take me a couple of goes. And finally, make a note of the credentials so that you can use them in a later lab. So, if you'd like to take the challenge approach, please pause the video now, follow the steps as shown here, and when you're finished, you can watch my walkthrough. If you prefer the step-by-step approach, or you're not going to do the lab yourself and you just like to watch me do the walkthrough, then I'll see you in the Azure portal now. You've logged into the Azure portal. Begin by taking a look at Azure AD Password Protection under Authentication Methods. Password protection should already be enabled. This will have occurred when you started the Azure AD Premium trial. You can add a custom banned password list. For example, a Cloud Guru. And save. Next, create a new user. In my case, Roberto Lopez. And his unique username is Roberto @ and then my domain. Copy the temporary password to the clipboard and create. Now move to a different private browser. Log in to the Azure portal. Enter the username of your newly created user. Paste in the temporary password. And now you can try the password, PASSW0RD exclamation mark. PASSW0RD exclamation mark. And the expected message is shown. We've seen that password too many times before. Choose something harder to guess. Enter Liverpool with a capital L and then a 1 exclamation mark at the end. So Liverpool 1 exclamation mark is too easy to guess as well. Try something else and make it a bit harder this time. Finally, a password which wasn't so easy to guess. Well, that concludes the Azure AD Password Protection Lab. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus, and welcome to this lecture on Azure AD Custom Domains. When you set up a new Azure account, Microsoft automatically creates a unique subdomain of .onmicrosoft.com for your Azure AD tenant. But that's not very usable. Users don't want to have to log on with dean@paulmschwarzenbergeroutlook.onmicrosoft.com. They want to use their company name. So, for example, adding acloud.guru as a custom domain name would allow a user to log on with their username dean@acloud.guru. Custom domain names are also a prerequisite for synchronizing your on-prem Active Directory with Azure AD. Steps to add the custom domain name are adding the custom domain name in the portal, and then verifying domain ownership using DNS. And usually, you would then make your new custom domain primary to set it as the default for new users. Any given domain name can only be associated with one Azure AD tenant. And now it's time for the Azure AD Custom Domain Lab. It's a bonus lab. I'd suggest it's probably only worth doing if you already own a registered domain. Otherwise, you'll be spending potentially quite a bit of money just so that you can do this lab. The domain must not have already been used and verified in Azure AD or Office 365. This lab is a prerequisite for one more lab, which is another bonus lab for AD Connect. The steps are 1. To create a custom domain in Azure AD. 2. Verify domain ownership. And test. If you'd like to take the challenge approach to this lab, pause the video now, follow these steps, and when you're finished, you can compare how you did it with my walkthrough. If you prefer the guided approach, or you'd just like to watch this as a demonstration, I'll see you in the Azure portal now. We're in the Azure portal. Add your custom domain name. In my case, it's learnsecurity.cloud. And add domain. To verify that you own your custom domain name, you're required to create a text entry to your domain name records with these details. A word of warning, ignore the @ symbol under alias or hostname. It won't work if you try and use it. Copy the value to the clipboard. And now log in to the portal of your domain name management system. In my case, I use Amazon Web Services as the domain registrar and also to manage DNS records for this domain. Select Hosted Zones, choose your domain name, create a new record set. For the type, choose TXT, paste in the value from the clipboard from the Azure portal, and change the time to live to 3600, and create. You'll now see your record for domain verification, so return to the Azure portal and press Verify. Your domain has been successfully verified. Now take the option to make primary and return to Custom Domain Names, where both domains should now be shown as available and your registered domain is now primary, in my case, learnsecurity.cloud. To test this, create a new user, Cecile, Fournier, username Cecile, @ your custom domain, and we've successfully created a new user in our custom domain. That concludes the Azure AD Custom Domain Lab. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus, and welcome to this lecture on Azure AD Connect. Businesses typically use a mixture of on-premise and cloud. They'll likely have an on-premise Active Directory and Azure AD. Microsoft has a concept of hybrid identity, where a single set of credentials is used across both on-prem and Azure. This provides ease of user management and fits with existing processes for joiners, movers and leavers, or JML. Azure AD Connect integrates on-premise Active Directory with Azure AD. A user can then log into their cloud applications with the same credentials that they use in the office. AD Connect can be used with all Azure AD license types. However, Azure AD Connect Health requires a premium Azure AD license. There are several different authentication options for Azure AD Connect, and a solid understanding of all of these will be needed for you to pass the exam. In all cases, the same credentials are used within on-premise Active Directory and Azure AD. The first option is password hash synchronization, or PHS. The hashes within your on-premise Active Directory are synced to the cloud, so that a user can authenticate to a cloud application using that password. It's then hashed, and the hash is compared with the synced value within Azure AD. The second option is pass-through authentication, or PTA, and this avoids storing the hashed passwords in the cloud. The user makes an authentication request to a cloud application. Azure AD hashes the password and then sends the hashed password to on-premise Active Directory for verification. The third option is federation using Active Directory Federation Server, or ADFS. This also avoids storing password hashes in the cloud. The user makes an authentication request to a cloud application. Azure AD returns a redirect so that the user then makes an authentication request to ADFS. The ADFS server returns a token along with another redirect, and then the user presents the token to Azure AD for verification. For all three types of Azure AD Connect, there's an additional option for single sign-on, or SSO, which prevents users from signing in twice. It's important to be able to recommend the most appropriate Azure AD Connect option, depending on customer requirements. The first column in this table represents password hash synchronization with single sign-on. The next column, pass-through authentication with single sign-on, and the last column is ADFS, Active Directory Federation Service. The first few common requirements are met by all options: sync users and groups from on-premise to the cloud, user sign-in to cloud services and applications with your on-prem password, single sign-on using corporate credentials, and mobile app access to Office 365. Sometimes there are security or regulatory requirements, which means that password hashes are not allowed in the cloud, and if that's the case, then password hash synchronization isn't a viable option. Cloud-based multi-factor authentication, or MFA, is available for all Azure AD Connect options. However, if on-premise multi-factor authentication is required, then only ADFS can provide that. Smart card authentication also requires ADFS, and so does the use of an on-premise password policy and account login restrictions within Active Directory domain services. Azure AD Identity Protection and Sign-in Risk requires the password hash to determine if credentials have been leaked. And finally, minimizing dependencies on on-prem infrastructure would lead one to select password hash synchronization, because then there's not a need to connect back to the on-premise Active Directory domain controllers for every single authentication attempt. Azure AD Connect is installed on a Windows server on-premise, which is a member of the Active Directory domain. Microsoft have provided an Express Settings option, which assumes password hash synchronization, synchronization of all users from a single AD domain, and the use of SQL Express as the database for Azure AD Connect. The custom settings options include pass-through authentication and ADFS, password hash synchronization as a backup to ADFS, Active Directory group writeback for Exchange, the use of SQL Server options instead of SQL Express, support for multiple Active Directory domains, filtering the synchronization by domain, organization unit, group or attributes, choosing which attributes to sync from on-prem to the cloud, and even implementing attribute transformation if needed. Azure AD Connect Health provides monitoring of Azure AD Connect and alerting if any issues arise. Azure AD Connect Health is installed on-premise, and components are AD Connect Health for Sync and AD Connect Health for ADFS. Azure AD Connect Health is viewed within the Azure AD portal. Information is provided on server performance, connectivity, and alerts. By default, alerts are sent to the global administrators. However, custom email destinations can also be configured. ADFS authentication metrics, ADFS risky IP address report, the last synchronization time, and any sync errors. In the next video, I'll be demonstrating installation and setup of Azure AD Connect. So when you're ready, I'll see you there. Hello Cloud Gurus and welcome to the Azure AD Connect lab. This is a bonus lab, the icing on the cake. It's more work to set up than most of the other labs. However, you'll definitely learn a lot if you go ahead. And don't worry, if you decide not to, that's fine. You'll still be able to do the rest of the labs on this course. Ensure you've already completed the Azure AD Custom Domain Lab. And you'll need a standalone Windows Server 2016. The detailed instructions and the code that you'll need to complete this lab are in the Cloud Guru AZ-500 GitHub repository. See the resources for this lesson for the link. Follow the instructions in the AD Connect folder README. If you'd like to take the challenge approach to this lab, pause the video now, follow the steps detailed in the GitHub repository, and when you're finished, you can compare how you did it with my walkthrough. If you prefer the guided approach, or you'd just like to watch this as a demonstration, I'll see you in the Azure portal now. We've logged in to the Azure portal. Let's start by taking a look at custom domain names. If you completed the Azure AD Connect lab, you'll have your own registered domain verified and set to primary, as well as your onmicrosoft.com domain. In my case, the verified domain is learnsecurity.cloud. And just a reminder, it's essential to have a registered domain name set up in Azure AD in order to do this lab. If you take a look at your users, you'll probably just have one user in your registered domain from when you tested the custom domain lab. Go ahead and delete this user, just to avoid any possible conflicts later. So your Azure AD is in a condition ready to start this lab. Let's take a look at the requirements for the Windows Server 2016, which will simulate your on-premise Active Directory. This is the Cloud Guru AZ-500 GitHub repository. I've put the link to this in the resources section for this lesson. I'll go into the AD Connect folder. The requirements for the Windows Server, which will simulate our on-premise Active Directory domain controller, are listed here. It needs to be a newly installed Windows Server 2016. It must be a standalone server not joined to a domain. The Active Directory domain services role should be added. However, the domain must not have already been created. And we need unrestricted outbound access to the internet. Once you've built a server that meets these requirements, go ahead and connect into it using Remote Desktop. I'll see you on the Windows Server desktop now. Here we are on the Windows Server desktop. This Windows Server will simulate our on-premise domain controller. In my case, I've set it up in Amazon Web Services, but it can be anywhere so long as the requirements are met. Start by browsing to the Cloud Guru AZ-500 repository on GitHub and download the contents to the Windows Server. Extract the zip file. Move into the AD Connect folder and open the Create Users and Domain PowerShell script by selecting Edit. Your Windows PowerShell ISE will open. Go down to lines 122 to 124 of the script. Edit from example.com to your own registered domain, which must exactly match the verified domain you've already set up in Azure AD. In my case, I'll replace example with Learn Security and com with cloud. and save. Before we run the script, let's take a look at it. The script starts by calling a function higher up on the page to create a new Active Directory domain forest. Creation of the domain will take a little while and require a reboot, after which you'll need to run the script again. Then the script sets up two groups, each again calling a function further up the page. The first is training, and the second one is called DevOps. Next, the script imports a CSV file in the same folder, containing user details. The script generates a random password for each user, and then creates the user account within Active Directory. Finally, the script joins members to the groups, using the other sample CSV files to establish group membership. Okay, it's time to run the script in an administrator PowerShell session. After the initial reboot, just connect back in via remote desktop again, using the same administrator credentials as before. Press the green play button to run the script. Enter a safe mode administrator password, which you shouldn't ever need. And confirm. Select Yes to all. And your new Active Directory domain server forest will now be installed. This will take a little while, so I'll fast forward the video at this point. After around 5 minutes, we've connected back in via remote desktop to the Windows server. Let's check to see whether our new Active Directory domain forest has been created. Go to Windows Administrative Tools, Active Directory, Domain and Trusts. You should see your new domain here. Let's return to the PowerShell script. Open the Create Users and Domain PowerShell script as before. And press the green play button to run the script. The Active Directory domain already exists, and the script is now setting up your user accounts and groups. Check out whether your users and groups have been created successfully by going to Windows Administrative Tools, Active Directory Users and Computers. Expand your new domain, and then Users. All your new users should be shown here. You'll also see your new groups, Training and DevOps. Your new domain is created. Its name exactly matches the verified domain in your Azure AD. You have users and groups set up, so you're now ready to install and configure Azure AD Connect. For this lab, you're going to install Azure AD Connect directly on this server. In the real world, in an enterprise environment, you should never install Azure AD Connect onto the domain controller itself. You should set up a separate server specifically for this purpose. Search for the Microsoft Azure Active Directory Connect download. Download and install. And the Welcome to Azure AD Connect screen should come up. Continue. Use Express Settings. Enter your Azure AD Global Administrator credentials. Confirm your password. And approve the sign-in request from your mobile device. Now, enter your Active Directory Domain Services Administrator credentials and install. Your Azure AD is being configured and synchronized with your on-premise Active Directory domain. This may take a little while, so I'll speed the video up. Okay, that took around 10 minutes, and as you can see was extremely straightforward. Configuration of your Azure AD Connect is now complete. Let's return to the Azure portal. Here are your users. Press refresh. You can see that all of the users from your on-premise Active Directory have been synchronized to the cloud. Let's take a look at groups. If we look at the source, you'll see previous groups created in the cloud. And all the other groups have been synced from your on-premise Active Directory via Azure AD Connect. Training and DevOps are the two groups which you created using the script. And the other groups are automatically created by Microsoft as part of the Azure AD Connect install process. Let's return to the Azure AD Connect overview. We can see from the sync status that the last sync was less than 1 hour ago, and that password hash sync has been enabled. Moving to Azure AD Connect Health, sync services are shown as healthy. And there should be no sync errors. That concludes the Azure AD Connect Lab. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus, and welcome to this lecture on Azure AD Identity Protection. Azure AD Identity Protection has two primary objectives: to protect identities in the cloud and to prevent the abuse by compromised identities. Azure AD Identity Protection capabilities include detection of vulnerabilities and risky accounts, investigation of risk events, and risk-based conditional access policies. There are three roles which grant permissions within identity protection. The Azure AD Global Administrator role has full access and can onboard a tenant to identity protection. The Security Administrator role has full access to identity protection but can't enable it. The Security Reader role has read-only access to identity protection. And the Azure AD Premium P2 license is required to use this feature. Example risk events within identity protection include sign-in from an anonymous IP address, email and password found in a public place, and suspicious activity such as failed logins followed by success. Example vulnerabilities are users without multi-factor authentication, or MFA, weak authentication for privilege roles, too many global admins, and the use of unmanaged apps. I'll take the opportunity to mention another useful Azure AD service, even though it's not directly part of Azure AD Identity Protection, and that's Identity Secure Score. Identity Secure Score provides a numerical value between 1 and 223 that rates how well you've configured Azure AD. It's a subset of Office 365 Secure Score, and provides benchmark security status for the industry type in which you're working. Improvement actions are also suggested. And it's available for all Azure AD license types. And now it's time for the Azure AD Identity Protection Lab. Ensure you have the credentials for the test user you created earlier. Make sure that user isn't a member of any group. In the Azure portal, go to Marketplace and search for Azure AD Identity Protection. Within Marketplace, press Create. Then go to All Services Azure AD Identity Protection Alerts. Change the risk level to medium and add your own email address for notifications, then save. Download the Tor browser and install. As the user within the Tor browser, connect to Tor, browse to the Azure portal, accept any cross-site scripting warnings, and then log in to the Azure portal as that test user. Back in your standard browser, as the global admin, explore All Services Azure AD Identity Protection, and view risk events. Also, take a look at vulnerabilities within Azure AD Identity Protection. You should generate a risk event, sign in from anonymous IP address, and a vulnerability, users without multi-factor authentication. You'll also receive an email alert, though this may take some time. If you want to take the challenge approach to this lab, please pause the video now, follow these steps, and then you can compare how you did it with my walkthrough. If you prefer the step-by-step approach, or you don't want to do the lab yourself, but just watch my walkthrough, I'll see you in the Azure portal now. We're in the Azure portal. Start by going to All Services, Marketplace, and search for Azure AD Identity Protection. And create. Then head over to All Services, Identity Protection, select Alerts and change the risk level to Medium. Add your email address for alerts and save. At this point, pause the video if you need to install the Tor browser. And within the Tor browser, go to the Azure portal and log in with one of your test users. In my case, Janet Harrison at learnsecurity.cloud. So your test user has now logged into the Azure portal coming from an anonymous IP address. Return to your global admin user in the other browser session. In Azure AD Identity Protection, currently we don't have any risk events, so I'll fast forward the video until we do. After about 5 minutes, you should see a medium level risk event. Sign in from anonymous IP address. Select the event, and you'll see more information. In my case, it's Janet Harrison, location London. Go back to Azure AD Identity Protection, Vulnerabilities. You should see a medium-level vulnerability, users without multi-factor authentication registration. In my case, I also have a low-level alert that I have too many global administrators. In my experience, vulnerabilities within Azure AD Identity Protection don't always show up on the screen straight away. So if you don't see anything here yet, just come back later. One last thing to look at, and that's whether we've received an email alert. And yes, I have received an email. User at risk detected. We detected a new user with at least medium risk in your default directory. And if you were to click on the View Detailed Report button, that would take you back to the Azure portal. Well, that concludes the Azure AD Identity Protection Lab. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello, Cloud Gurus, and welcome to this lecture on tenants, subscriptions, and roles. When we set up our Azure account, Microsoft automatically created an Azure AD tenant for us. That Azure Active Directory can be used as the central identity source for Office 365 and also Azure resource subscriptions. And we can have more than one resource subscription if we want to. For example, one for user acceptance testing, another for production, and another for development. Roles in Azure represent a set of permissions. There are two main role types in Azure. Azure Active Directory Administrator roles, which relate to permissions within Azure Active Directory itself, and Azure Resource roles, or RBAC, Role-Based Access Control, which represent permissions on subscriptions and resources within those subscriptions. Roles can be assigned to users directly. They can also be assigned to groups. However, at the time of this recording, only Azure Resource roles can be assigned to groups. And roles can also be assigned to app registrations. Role definition types can be Microsoft built-in roles, or it is also possible to customize your own roles. However, at the time of this recording, that's only available for Azure Resource roles. And it's worth noting that the Microsoft account, which you used to set up your Azure account in the first place, created the Azure AD, so automatically receives the Global Administrator role. Let's look at some examples of role assignments in Azure. In our first example, we want to allow an individual to audit resources in our production subscription without being able to make any changes. We'll set up a group called auditors, and we'll use a resource role type, and the actual role that we'll use will be the security reader role. The scope to which we'll assign that role is the production subscription. Next, let's take a look at how we'd set things up for a continuous delivery server like Jenkins. Jenkins needs to run without any human involvement, so we'll set up a service principal for it to use. We'll assign the role to the app registration for Jenkins, sp-Jenkins. It's a resource role type, and we'll choose the contributor role to allow it to make changes and create things. And the scope to which this role is assigned will be the dev, UAT and prod subscriptions. Our final example is the help desk. Help desk staff need to be able to create new user accounts, delete user accounts and reset user passwords. At the time of this recording, we can't assign Azure AD roles to groups, so we're going to assign them directly to each user in the help desk. The user is Zhang Y. It's an Azure AD role type, and we'll choose the user administrator role. The scope to which that role is assigned is the Azure AD tenant. There are three fundamental resource roles within Azure. The owner role allows all actions, including assigning rights to others. The contributor role includes nearly all actions, including creating and deleting resources. However, you can't assign rights to others. And the reader role provides read-only access. To view the role assignments for a subscription, go to All Services, Subscriptions, Access Control, Role Assignments. In this example, you can see that I've assigned the contributor role to an admin service principal with a scope of the whole subscription. I've also assigned the owner role to the admins group, and again the scope is the entire subscription. An API is an application programming interface and allows one computer program to communicate with another. So for example, if we want to use PowerShell on our laptop to create a virtual machine in Azure, that will use an API. Different Azure services each have their own API. For example, the Graph API for Azure AD, Resource Manager APIs for Azure subscription resources, and the Office 365 Management API, which can be used to obtain Azure AD audit data. A service principal must be granted consent in order to use Azure AD APIs, and a service principal must be assigned a resource role for a subscription in order to use Resource Manager APIs. API authentication and authorization uses OAuth 2 with OpenID Connect. APIs are used by, amongst other things, Azure PowerShell, Azure CLI, command line interface, and many third-party applications, for example, Terraform by HashiCorp. The last topic we'll cover in this lesson before the lab is transferring subscriptions between tenants. This may happen occasionally, for example, if one company purchases another one and then wishes to consolidate the identities of both sets of employees. If you do need to do this, then sign in as admin to the Azure Account Center. That's what you use when you set up your Azure account in the first place. Select the subscription to transfer, and then you can transfer the subscription and specify the new owner. The new owner will receive an email with a link, can click on the link, and then accept the new subscription. It's important to note that all role assignments in the original tenant will be permanently deleted and not transferred, so would all need to be recreated. So now it's time for the Azure Subscription Role Lab. Start by removing any baseline protection policies for MFA, so that you don't have to use MFA for all the different steps in this lab. After you've done that, create a group called DevOps within Azure AD and add a user, for example Alexis, as a member of the group. Assign the contributor role to the DevOps group with the subscription as the scope. Then, in another browser, log in as that user, create a resource group, and try and assign another user rights to the subscription. And you shouldn't be able to do this. And after that, delete the resource group. If you want to take the challenge approach to this lab, please pause the video now, follow the steps as shown here, and when you're finished, you can watch my walkthrough. If you'd prefer to take the guided approach, or you'd just like to watch my walkthrough, I'll see you in the Azure portal now. We're in the Azure portal. You should currently be logged in with a global admin user. This global admin user will most likely have complete rights to Azure AD. However, you probably haven't yet assigned rights to your Azure subscription. Let's begin by disabling any baseline protection policies within Azure, just to make the lab more straightforward. You'll see that the baseline protection policy, require MFA for admins, is enabled, so select the policy disable it, and save. You should now log out from your global admin session and log back in with the Microsoft identity you used to create the Azure account originally. Now that you've logged in with your Microsoft account, your first task is to grant the global admin user full rights to the subscription. Head over to All Services, Subscriptions, select your subscription, Access Control, and add the global admin user as co-administrator. That should mean you won't need to log back in again with this Microsoft account. If you completed the optional Azure AD Connect lab, you'll already have a whole load of users which have been synced from your on-premise Active Directory. And as well as the users, you will have some groups, including the DevOps group. If you didn't do the Azure AD Connect lab, that's fine. Just manually create the DevOps group and one or two users which you should make members of this group. Move back to Subscriptions, Access Control, and add a role assignment. Select the contributor role, choose the DevOps group, and save. You can now check the role assignment. And next, log in as your test user in another browser. In my case, Alexis, who is a member of the DevOps group. Alexis Tremblay at learnsecurity.cloud. You're now logged in as your test user. In my case, that's Alexis, who is a member of the DevOps group, so should have contributor rights to the subscription. Let's test this. Go to Resource Groups and add a resource group. Choose your favourite region, review and create. You have now created a resource group. Next, go to All Services, Subscriptions, choose your subscription, Access Control, and you won't be able to add a role assignment. It should be greyed out. Head back to Resource Groups and delete your resource group. Confirm by entering the name and delete. The resource group has now been deleted. That concludes the Role Assignment Lab. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus and welcome to this lecture on Privileged Identity Management. Azure AD Privileged Identity Management, or PIM, is actually one of my favourite tools within Azure. You can use it to minimise and control user accounts that have privileged access, and reduce the risk of malicious or accidental actions in Azure. Key features of Privileged Identity Management, or PIM, includes just-in-time privileged access to Azure, assigning time-bound access to resources within Azure subscriptions, so for example just 4 hours, requiring approval to activate privileged roles, and enforcing the use of multi-factor authentication, MFA, to activate those roles. You can require a user to justify why they need a particular role, and receive notifications when role approval is required. PIM can be used for one-off or scheduled access reviews so that you can see who actually has what roles and whether they really need them or not. PIM includes a full audit history and can be used to manage both Azure Active Directory and Azure Resource roles. An Azure AD Premium P2 license is required. In order to enable Privileged Identity Management, you require the Azure AD Global Administrator role. That global admin user enables PIM and then automatically becomes PIM Administrator. So in a real enterprise environment, think carefully about which user you use to enable PIM. Other global admins don't automatically become PIM admins. The PIM admin role is known as the Privileged Role Administrator, and that can be assigned to others. PIM admin requires multi-factor authentication, and bear in mind that the Microsoft account doesn't necessarily support MFA, so shouldn't be used. The Azure AD Security reader role has audit access to PIM. Here's an example approval workflow for privileged identity management. The user needs to delete a resource in production, maybe a virtual machine. The user has an eligible role of contributor for the prod subscription. The user requests activation and is required to perform an additional authentication step using MFA. The user enters a justification as to why they need to delete that virtual machine, and then the PIM admin receives an email notification. The PIM admin checks the details and approves, and the user role then becomes active from the activation start time. And the user is now able to delete the resource, in this example a virtual machine, until that activation period expires. I'll now demonstrate Azure AD Privileged Identity Management, so when you're ready, I'll see you in the next video. Hello Cloud Gurus and welcome to the Privileged Identity Management Lab. First, log in as the global admin user. Step 1 is to create 2 users, assign the global admin and subscription owner roles to those users. Step 2, enable privileged identity management. Step 3, sign up privileged identity management or PIM for Azure AD roles. And step 4, use the PIM Azure AD roles wizard and change the owner role for your 2 users to eligible. Then, in a separate private browser tab, log in as one of your users. Go into PIM and activate the Azure AD Global Admin role for 1 hour and check that as that user, you're able to create another user. Then, back in the Global Admin browser, onboard the resource subscription to Privileged Identity Management. Create an access review for the owner role with self-approval and start the access review. Back in your users browser, use PIM to self-approve the continued use of the owner role. And finally, as the global admin user, stop the access review and take a look at the results. If you would like to take the challenge approach to this lab, pause the video now, follow the steps as outlined here, and when you're finished, you can compare how you did it with my walkthrough. If you prefer the guided approach, or you just want to watch this as a demonstration, then I'll see you in the Azure portal now. We've logged into Azure with global admin credentials. The global admin account is co-administrator, so has full rights to both Azure AD and your Azure subscription. The first step is to enable privileged identity management, so go to PIM and consent to PIM. You'll be asked to verify your identity. So approve the sign-in request to your mobile device and consent. Start by signing up Privileged Identity Management for Azure AD roles. Select Sign Up. And PIM is now discovering privileged role administrators such as global administrators within your Azure AD tenant. As this is the first time you're using PIM within your tenant, begin with the Azure AD roles wizard. Firstly, discover privileged roles. You should see something like this. In my case, there's 4 global administrators, 1 security administrator, and 1 privileged role administrator. Let's have a look at who the global admins actually are. We can see the Microsoft account, the global admin account, and 2 other users, in my case, Elias and Hassan. These users may well not actually need the global admin role, or at least not all the time. The security admin role has been assigned to the global admin, and the privileged role administrator also. This is to be expected as the global administrator user onboarded PIM. So next, let's convert the 2 other users, in my case Elias Meyer and Hassan Wulandari, to eligible members. This means that they will now have to request activation to become a global admin and justify why they need it. The results of the wizard can be seen under Members, where your users, in my case Elias and Hassan, both have the global administrator role as an eligible role. To test this, log on as one of these users in a separate browser. Elias Meyer at learnsecurity.cloud. You're now logged in as your test user, in my case Elias. Search for PIM. And view My Roles. The Global Administrator role is not currently active, so it's an eligible role. Let's suppose Elias needs to create a new user. Press Activate. The user will need to verify their identity before proceeding and set up the mobile app. Once this is done, return to My Roles within Privileged Identity Management and press Activate again. The activation duration is set at 1 hour, so enter an activation reason, create a new user, and activate. So PIM is evaluating the request and activating the Global Administrator role for a period of 1 hour. In this example, the role was activated automatically on request. However, you can configure policy to require administrator approval before activating an eligible role. To test this, head over to Azure Active Directory and check that you can create a new user. Next, return to your global admin browser. Refresh, and you should see the Global Administrator role as now active for your test user, in my case Elias, terminating in about 1 hour's time. Now, head back to Privileged Identity Management, Azure Resources, Discover Resources. You should discover your free trial subscription, and now onboard the resource subscription for management. Return to Privileged Identity Management, Azure Resources, and you should now see 4 owners to the subscription. Take a look at access reviews. Change the settings to disable mail notifications and reminders, and save. Go back to access reviews, create a new review. The start date will be today. You could make it a scheduled event. However, for this lab, leave it as a one-time review. The end date is set at 1 month after the start date. Leave everyone in scope and select the subscription owner role. Allow each user to approve their own access and start. The access review is now being created. Let's take a look at it. You'll see all the owners of the subscription, in my case 7, and at the present time, none of the owners have reviewed whether they actually require the role. Return to your test users browser. In my case, that's Elias Meyer. Go to Azure AD Privileged Identity Management and review access. Your user's access review is here. Normally, if you'd enabled email notifications, your test user would have received an email asking them to log in and say whether they actually required this access. Your test user should select their own account, enter a reason as to why they require the access, and then approve themselves. The user, in my case Elias, has self-approved his continued use of the owner role. Now, return to your global admin browser and refresh. One of your users has now been approved. In my case that's Elias, and the others haven't yet been reviewed. You can wait until the end of the month, however for this lab, stop the review now. Go into results, and you can now see your detailed results. One of your users will be approved, reviewed by themselves, and the others haven't yet been reviewed. In this case, there's no recommended actions. You could have configured the review so that automatic remediation took place, for example, removing the role from anyone who hadn't replied during the month. So that concludes the Privileged Identity Management Lab. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus and welcome to Azure AD exam questions. I'm going to give you 2 example questions similar to those which may come up in the AZ-500 exam. The skills measured are managing identity and access from the Microsoft exam blueprint. You should allow yourself a maximum of 3 minutes per question. Here's the first exam question. You have 3 minutes to note down your answer. Please pause the video now and when you're finished, press play. Okay, so you've written down your answer. How did you get on? Well, let's take a look at the requirements. The first requirement, log on to the Azure portal with on-premise Abrantia credentials, is met by all 4 possible answers, as they all include AD Connect. The second requirement, require MFA for global admins, can be achieved either in Azure AD settings or as part of a baseline protection policy. However, neither of these options requires Azure AD Premium. So, as the last requirement is to minimize costs, we can eliminate B and D. That leaves A and C as possible choices. Now both of these meet the requirements to not store password hashes in the cloud. However, the ADFS option requires more servers on-premise. You would normally have 2 ADFS servers for resilience, as well as the AD Connect server. So the right answer is C, AD Connect, pass-through authentication with Azure AD Standard. Here's the second exam question. You have 3 minutes to note down your answer. Please pause the video now and when you're finished, press play. Okay, so you've written down your answer. How did you get on? Well, let's take a look at the requirements. Abrantia Corp wishes to restrict login with Azure AD Global Admin and Subscription Owner roles to only certain IP addresses and only make the roles available to users for 4 hours. How can this be achieved in the most cost-effective manner? Well, Azure Firewall, mentioned in 2 of the options, is a network-level control to protect virtual machines in Azure, so it won't help us with restricting login to Azure AD. So we can immediately eliminate A and C. That leaves B and D, both of which would meet the functional requirements. Conditional access can restrict IP addresses, and Privileged Identity Management, or PIM, can make the roles available to users for just 4 hours. Conditional access requires Azure AD Premium P1 or P2 edition. However, PIM has to have P2. So we can eliminate B, and the correct answer is D, Conditional Access and Privileged Identity Management with Azure AD Premium P2. Well, that concludes this section on Azure AD exam questions. So when you're ready, please feel free to move on to the next lecture. Congratulations, Cloud Gurus! You've reached a milestone! You've covered 25% of this course. What do I mean by that? Well, in the AZ-500 exam blueprint, there are 4 areas. Manage identity and access. 20 to 25% of the questions will cover this topic. Implement platform protection. Manage security operations. And secure data and applications. You've completed Manage Identity and Access, which according to the Microsoft AZ-500 exam blueprint covers 20 to 25% of the questions. Hello Cloud Gurus and welcome to this chapter on Protect Virtual Networks. Protect Virtual Networks forms an important part of the Implement Platform Protection key skill for the AZ-500 Azure Security Technologies exam. We'll begin with lessons on virtual networks and virtual network peering. We'll move on to look at network security groups, application security groups, remote access management, connections to on-prem data centers using VPN and ExpressRoute, network virtual appliances and custom route tables, Azure Firewall, and Network Watcher. The labs in this section of the course are particularly important, as the infrastructure you create will be used in many later labs. After the labs, don't delete virtual networks, network security groups, and virtual machines. However, do stop the virtual machines when they're not in use to reduce cost. A word on licenses. Depending how long you've taken on the course so far, it's possible that your initial 30-day Azure AD Premium license may have expired. For another 30 days, activate the Enterprise Mobility free trial. However, it isn't essential that you do this for labs in this section of the course. And finally, if you have any questions and comments throughout the course, please remember to use the course discussion room. I'll be taking part in this myself and answering questions. However, it's not just about me. You can answer questions from other students, and that's a great way to reinforce your own learning. So that's it for this introduction to Protect Virtual Networks. When you're ready, I'll see you in the next lecture. Hello Cloud Gurus, and welcome to this lecture on virtual networks. Virtual networks are the foundation of Azure Network Security. Each virtual network is defined with an IP address range, such as 10.10.0.0/16. That uses CIDR notation, or classless interdomain routing. Nearly always in Azure we use private address spaces. However, it is actually possible to use public address spaces as well, though the public addresses aren't directly routable from the internet. DNS server addresses are set at the virtual network level. By default, Azure DNS is used. However, it is possible to instead, or as well, configure your own private DNS servers. There's a default set of routes which are used within the virtual network, including a default route to the internet. It is possible to override these with specific route tables at the subnet level. Azure virtual networks contain one or more subnets. For example, a front-end subnet with address space 10.10.1.0/24 and a back-end subnet 10.10.2.0/24. You'll see on the screenshot that there are only 251 IP version 4 addresses available within each subnet. That's because Microsoft reserves addresses for its own use. The very first address, .0, in the case of a /24, is the network address. The last address, which would be .255 for a /24, is the broadcast address. And the first three usable addresses, which would be .1, 2 and 3 in the case of a /24, are reserved for Azure services. The smallest supported subnet in Azure is a /29, the largest supported subnet a /8. A custom route table can be associated with each subnet. Service endpoints are set at the subnet level. They provide direct routes to Azure PaaS or Platform as a Service services, such as Azure Storage or Azure SQL. And now it's time for the Azure Virtual Network Lab. In this lab, you'll build some infrastructure, shown in this diagram. A virtual network called app-eus, that's for East-US, -vnet, which will be in its own resource group, app-vnet-rg. The location should be East-US, the address space 10.10.0.0/16. It should have two subnets, a front-end subnet and a back-end subnet, with the address spaces shown here. The front-end subnet should have an Azure Storage service endpoint, and the back-end subnet, Azure Storage and Azure SQL. When you're finished, keep the virtual network, because you will need it to use in later labs. If you'd like to take the challenge approach to this lab, please pause the video now and go ahead, build the infrastructure using this diagram. If you prefer the guided approach, then I'll see you in the Azure portal now. We're logged into the Azure portal. We'll start by creating a resource group. So add a new resource group and name it app-vnet-rg. Use the East-US region and create. We'll go to the resource group, then select virtual networks, add a new virtual network. The name should be app-eus for East-US -vnet. We'll make the address space 10 10.10.0.0/16. Select the app VNet RG resource group. Keep the location as East-US. And we'll take the opportunity to put in our first subnet, front end, 10.10.2.0/24. We'll enable service endpoints and select storage. Deployment of the virtual network is now in progress. Your virtual network has been created. The address space is 10.10.0.0/16, and currently you just have the one front-end subnet. Next, create a new subnet. This one should be called backend. The address space should be 10.10.4.0/24. And service endpoints should be SQL and storage. Okay, you've created your virtual network subnets and service endpoints. Keep the virtual network, as you'll need to use it in later labs. And that's all for now. So when you're ready, I'll see you in the next lecture. Hello Cloud Gurus, and welcome to this lecture on virtual network peering. Virtual network peering in Azure connects two virtual networks or VNets together. It's important to ensure that there's no overlap of address spaces. The VNets can be in different subscriptions. And programmatically, the peering needs to be created in the context of each VNet in turn. Configure forwarding settings. These may be needed if you're implementing a hub and spoke architecture, and also gateway transit settings if needed. Cross-region peering is supported, which uses the Microsoft backbone. Data transfer charges between VNets over peering connections can apply. Here's an example of virtual network peering based on one of the customers who I've worked with. We have a management or shared services VNet in the East-US region, and separate virtual networks for each of the applications. Peering connections allow the applications to connect to the shared services VNet. And there's a secondary region, West-US, which also contains a management VNet peered to application VNets. Finally, peering is set up from the East-US to the West-US region for replication and disaster recovery purposes. And now it's time for the Virtual Network Peering Lab. Ensure you've already completed the Virtual Network Lab. Create a second virtual network. The name should be app-WUS for West-US-VNet. Location should be West-US. The address range 10.20.0.0/16 with a front-end subnet and back-end subnet as shown. Peer the VNets together and ensure the peering status is shown as connected. And when you're finished, keep the virtual networks for use in later labs. If you'd like to take the challenge approach to this lab, please pause the video now, go ahead and set up the second virtual network and peer them together. If you prefer the guided approach or you'd just like to watch my walkthrough, then I'll see you in the Azure portal now. We're in the Azure portal. Start by creating a new virtual network. The address space should be 10.20.0.0/16. We'll use the same resource group as before. Location, West-US. The front-end subnet will have an address range 10.20.2.0/24 and we'll enable the Microsoft Storage service endpoint. The virtual network is being deployed. Your second virtual network has now been created. Add the second subnet, backend. The address range should be 10.20.4.0/24. and you should give it SQL and storage service endpoints. The backend subnet has now been added to the virtual network. Next, go to peerings, add a new peering, select the East-US virtual network, leave virtual network access enabled in both directions, and press OK. The peering connections are being added, and your peering connection is now shown as connected. Select the peering connection to configure details, such as forwarded traffic settings, gateway transit, and remote gateway settings. That concludes the Virtual Network Peering Lab. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus, and welcome to this lecture on network security groups. A network security group in Azure is a stateful packet filtering firewall to protect virtual machines. A 5-tuple approach is used based on source, source port, destination, destination port, and protocol. Each network security group rule has a number of parameters associated with it. The direction of traffic can be inbound or outbound. The priority of the rule is a numerical value. The lower the value, the earlier it is evaluated in order. The lowest value, which we can assign as Microsoft customers, is 100, and the highest 4096. Each network security group rule must have a unique name. The source can be an IP address format, or it can be a service tag such as Azure Load Balancer or an application security group. We'll be talking about these later in this lesson. The source port is not actually shown within the portal, but can be a value, a list, or a range. The destination, like the source, can be in IP address format, a service tag, or an application security group. The destination port can be a value, such as 3389 for remote desktop, or a list, or a range. The protocol can be TCP, UDP, ICMP, or any. Action is allow or deny. And optionally, you can enter a text description of the rule. Microsoft includes default rules within each network security group. The priority of these rules are set to 65,000 to 65,500, so they're evaluated after all of the rules which we set. They cannot be deleted. If you need to override the Microsoft default rules, insert a rule with a lower priority number and a deny action. Let's take a look at an example. The Microsoft default rule 65,500 at the bottom says deny all inbound, and from a security point of view that's good because it prevents access to virtual machines from the internet unless we set another rule to allow it. However, we have two additional default rules, 65,000 and 65,001. The first allowing everything in from within the virtual network, and the second rule allowing Azure load balancers. We may wish to disallow this to reduce overall risk by providing greater segmentation of machines within the virtual network. To do this, we create a new rule with priority 4000 called block inbound that denies all traffic. Microsoft's default outbound NSG rules are 65,500, deny all outbound. From a security point of view, that's a good thing. And then we have 65,000 and 65,001 allowing all traffic out to not only the virtual network, but the internet as well. From a security point of view, that's not a good idea because there's a risk of data exfiltration and command and control via the internet. In this example, we've created a block outbound access rule which denies all traffic and has priority 4000, so negates the 65,000 and 65,001 Microsoft rules. Finally, we create our own rules, 200 and 210, with that specific traffic which we actually need to allow outbound. Network security groups can be assigned to a network interface card, or NIC, subnet, or both. NIC NSGs are assigned to a specified virtual machine NIC, whereas subnet NSGs are assigned to all virtual machines in that subnet. In either case, the packet filtering actually takes place on the virtual machine NIC. If a virtual machine has NIC and subnet NSGs, then both rule sets apply. For inbound rules, the subnet NSGs are processed first, then the NIC NSGs. For outbound rules, it's the other way around. NIC NSGs are processed first, then the subnet NSGs. Virtual machines in Azure may need to connect to PaaS services such as Azure SQL, Cosmos DB, or Data Lake. To do this, we make use of a service tag within an NSG rule, in this example sql.east.us. A service tag is a group of IP addresses to simplify NSG rule management, and those IP addresses are managed and updated by Microsoft. Examples: Azure Load Balancer, Internet, Azure Cloud, sql.east.us, Azure Key Vault.west.us, and Azure Active Directory, which is a global service. You can download the collection of IP addresses for each service tag programmatically for use in on-premise firewall rules if needed. Application security groups are used within network security groups as a way of simplifying NSG management. They're effectively labels for virtual machines, and a rule only applies if a virtual machine NIC has the ASG associated with it. In the example shown, HTTPS is allowed inbound to the web servers, and web servers are allowed to communicate with database servers using the SQL protocol. Microsoft recommends that, if possible, you should avoid using NIC NSGs and instead use subnet NSGs with application security groups to simplify management. To implement application security groups, begin by creating an ASG within a resource group. Then include the ASG within network security group rules. Finally, associate the application security group with the virtual machine network interface card. More than one application security group can be associated with a single virtual machine NIC. That can be useful for simplifying the rule base. A limitation of application security groups is that the ASGs, NSGs, and virtual machines must all be in the same subscription and region. That concludes this lesson on network security groups in Azure. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus and welcome to the Network Security Group Lab. You'll already have a VNet from the previous Virtual Network Lab. That will be a VNet with an address space of 10.10.0.0/16 and a front-end and back-end subnet. You'll add to this network infrastructure by creating a Bastion and App Server Application Security Group and a single subnet network security group. Create a Windows Server virtual machine in the front-end subnet and an Ubuntu Linux virtual machine in the back-end subnet. Apply the single NSG to both subnets and make use of application security groups. Your goal is to allow inbound remote desktop to the Windows virtual machine from the IP address of your laptop, to allow SSH from the Bastion to the app server, and to ensure that all other inbound traffic is blocked. To test this, remote desktop from your laptop to the Bastion, that should connect, and SSH from the Bastion to the app server as well. Have a go at pinging the app server from the Bastion, and that should be blocked. When you're finished, keep the resources, because you'll need them in later labs. However, to minimise cost, I'd suggest shutting down the virtual machines. If you'd like to take the challenge approach to this lab, then please pause the video now and go ahead, build the resources, do the tests based on the information you've seen in this video. If you'd prefer to take the guided approach, or if you'd just like to watch my walkthrough, then I'll see you in the Azure portal now. We're in the Azure portal. Start by searching for application security groups and add an application security group. Use the existing app VNet RG resource group. Call the first application security group Bastion in the East US region. The deployment of the Bastion application security group is underway, and now it's completed. Go back to application security groups, add, select the same resource group, and call this application security group App Server in the East US region. The App Server application security group deployment is in progress. And now, both application security groups have been created. Next, go to Network Security and select Network Security Groups. Add a new security group. The name should be app-eus-nsg. We'll use the same resource group as for the other elements of the infrastructure and keep the location as East US. The network security group is being deployed, and deployment of the network security group is now complete. You'll see the Microsoft default inbound and outbound NSG rules. Select Inbound Security Rules, Add, open a new browser tab, search for IP address, copy your public IP to the clipboard, select Add. The source type should be IP addresses. Paste in the IP address from your clipboard. Leave the source port ranges as star for any. The destination should be Application Security Group. Bastion. The destination port should be 3389 for remote desktop. Protocol is TCP. Leave the action at allow and the priority at 100. Rename the network security group rule to RDP inbound. Optionally add a description and add. Next, select Add. For this rule, the source should be an application security group. Bastion. Source port should be star. Destination should be another application security group, this time the app server. Destination port should be 22 for SSH. Protocol TCP. Action allow. Priority 110. Name SSH. Inbound. We need one more rule to meet the requirement to block all other inbound traffic. The source should be left at any. Source port star. Destination any. Destination port ranges should be set to star. Protocol any. Action deny. Priority 4000. Name deny all in. You've completed your network security group. The next stage is to associate your network security group with your subnets. Select Subnets, Associate, choose the app EUS VNet, Backend, press Associate again, and choose the front end. Both subnets are now associated with your network security group. Select Virtual Machines, Add, choose the app VNet RG. Your first virtual machine can be the Bastion, so give it a name, app EUS Bastion. The region should be East US. Image type is a Windows Server 2019 data center. Leave the size at standard DS1 version 2. Enter a username, a password, and confirm your password. You can leave the inbound port rules for now, as we'll set those later, and press Next Disks. Change the disk type to standard SSD. Press Next Networking. We'll leave the virtual network at app EUS VNet. For the Bastion server, we're going to put that into the front-end subnet. We want to have a public IP for the Bastion, and we don't want to have a NIC NSG. We'll rely on the subnet NSG. Press Next, Management. We don't need boot diagnostics. Press Next, Advanced. review and create, and create. The Windows virtual machine is being deployed. I'll fast forward the video until it's complete. The Windows virtual machine has now been created. So go to the resource, select Networking, select Application Security Groups, configure the Application Security Groups, choose the Bastion ASG you created earlier, and save. The Bastion ASG is now associated with the network interface of your Bastion server. Select Virtual Machines, press Add, choose the same resource group as before. Your virtual machine name should be App Server. As usual, the East US region. We'll leave the image type as Ubuntu Server 1804. Change the size, we don't need such a large server for Ubuntu. Clear the premium disk filter. Select A1. Change the authentication type to password. Enter a username. Enter a password. And confirm your password. Select Next, Disks, and Next, Networking. Leave the application server on the back end. We don't want a public IP on the back-end subnet. Leave the NIC Network Security Group setting as none, as we have a subnet NSG. Press Next, Management. We don't need boot diagnostics. And now press Review and Create. Your Ubuntu server is being deployed. I'll fast forward the video until that's complete. The Ubuntu server is now deployed, so go to the resource, select Networking, Application Security Groups, configure the Application Security Groups, choose the App Server ASG, and save. You're now ready to test your infrastructure. Open your remote desktop client. If you're using a Windows 10 laptop, that will be built in. If you're using a Mac, then you can get Microsoft Remote Desktop from the App Store. I'll see you on the Windows server. We've logged into our Windows server in Azure from our laptop using Remote Desktop. The fact that you've successfully achieved this indicates that your network security group rule is correct. You could double check this by trying to remote desktop in from a different public IP address, which should be blocked. Next, we need to go back to the Azure portal, select App Server, and copy the private IP address of the Ubuntu server to your clipboard. Return to Remote Desktop. Start Windows PowerShell. SSH, then your Ubuntu username, and paste in the private IP address. You should now have received an SSH prompt. Type yes, and enter your password. Congratulations! You have successfully SSH'd from your Windows server onto your Ubuntu machine. Exit. And now try pinging the IP address by typing ping, paste in the IP address, and we can see that the request times out. So you've successfully tested your NSG rules. All that's left is to shut down the virtual machines to save money. Return to the portal. Select your virtual machines and stop. We don't want to delete them because we will be using them in later labs on this course. That concludes the Network Security Group lab. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus and welcome to this lecture on Remote Access Management. DevOps, application developers, and infrastructure engineers need to be able to access Azure resources for testing and troubleshooting. This usually takes place with a highly privileged account. Typically, the DevOps user connects to the Azure portal or API for remote administration. If the DevOps user is also looking at their email on the same workstation, the DevOps user could click on a link in a targeted mail, and then an attacker could steal credentials or bring the workstation under his or her command and control. So there's a substantial risk of administration machine compromise and cloud account takeover. Microsoft recommend a series of operational security fundamentals. I've put the link for this in the resources section for this lesson. First up is a dedicated workstation for privileged activities, with no productivity applications like email. Limit outbound internet access from this admin workstation. Restrict local permissions. Join Windows servers to the domain and apply group policy. Use multi-factor authentication. Install anti-malware software and monitor Azure activity. DevOps users commonly need to be able to administer virtual machines in Azure. This could be using remote desktop for Windows or SSH for Linux. A common architectural pattern to improve security in this situation is to require the DevOps user to remote desktop onto a Bastion server and then from the Bastion server connect via RDP or SSH to the virtual machines within Azure. The first option for connecting to the Bastion or jump server is a private connection from on-premise. This could be using site-to-site IPsec VPN or ExpressRoute. The second option is a public connection via the internet. In this case, a public IP address is assigned to the virtual machine, and access is limited using a network security group. However, this isn't recommended from a security perspective. It's just too easy to misconfigure that NSG and end up allowing inbound access from anywhere on the internet. The third way that you can connect to the Bastion server is a client connection via Azure VPN. This uses point-to-site or P2S, for which there are a few options. OpenVPN, a standards-based approach over SSL, Secure Socket Tunneling Protocol or SSTP, and IKE version 2. There can be scaling issues with large numbers of users due to the need to distribute certificates. However, this is a pretty good approach, particularly for proof of concepts. Another option for managing servers within Azure is to use Azure Bastion, which is a managed platform as a service. This provides the ability to remote desktop or SSH to Azure virtual machines. The Azure Bastion is provisioned inside the VNet and uses SSL via the Azure portal. The DevOps user logs into the portal as usual via SSL, and then, via the Microsoft infrastructure, connects to the Azure Bastion, where the user can then open a remote desktop window within the portal to a Windows server, or SSH command line to a Linux server. That concludes this lesson on remote access management in Azure. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus, and welcome to this lecture on Azure Hybrid Networks. Most organizations start with an on-premise network and then begin migrating to the cloud. At this point, they'll have a hybrid network, meaning a mixture of their on-premise network and cloud resources. There are several different ways to connect an on-premise network with Azure. Azure VPN is a fully managed service with built-in resilience, allowing you to set up IPsec tunnels over the internet between your on-premise appliances or firewalls and your virtual networks in Azure. ExpressRoute is an extension of an organization's existing wide area network, or WAN, into Azure, using circuits provided by a telecoms provider. ExpressRoute connections don't go over the public internet. They offer high reliability and speeds, with consistently low latency. Bandwidths can be up to 10 gigabits per second, and there are many options for high resilience. However, setting up ExpressRoute is not an overnight job. The typical lead time for an ExpressRoute circuit is 90 days, and the solution should be designed, planned, and implemented with full involvement of your organization's network team. It's also possible to set up ExpressRoute as your primary connection with Azure, and Azure VPN Gateway as the backup connection. Finally, there's the option to use a Network Virtual Appliance, or NVA, set up as an infrastructure as a service virtual machine and to configure an IPsec connection over the internet between your on-premise VPN or firewall and your Azure virtual networks. We'll now look at Azure VPN and network virtual appliances in more detail. Starting with Azure VPN, Azure VPN Gateway connects your on-premise networks to Azure via site-to-site IPsec channels over the internet using industry standard protocols such as IPsec and IKE version 2. It's compatible with all the major firewall and VPN vendors, which you might already have on-premise, for example Cisco, Check Point, Juniper or Palo Alto. As we mentioned in the lecture on remote access, Azure VPN also allows you to connect to your Azure virtual machines from a laptop using point-to-site VPN. The Azure VPN is implemented within a dedicated gateway subnet inside your virtual network. The VPN gateway can connect to more than one on-premise network, as shown here, or to the same on-premise network but to multiple firewalls for resilience. As usual, be careful to ensure that there are no overlapping network ranges in your different networks. Once the VPN tunnel is established, routing from virtual machines in Azure to the on-premise network ranges is established via the gateway. There are four main pricing SKUs for Azure VPN: Basic, VPN GW1, VPN GW2, and VPN GW3. If you want to make your VPN resilient across availability zones, and you're in a region which supports them, just add AZ at the end of any of the SKUs other than the basic one. Whether or not you're using availability zones, all the other parameters remain the same. The lowest cost SKU is the basic one, which is a legacy SKU not recommended for production use, and it's the only SKU which supports IKE version 1. However, from a security perspective, IKE version 2 should always be used. It's worth noting that it's not possible to upgrade from a basic SKU to one of the production SKUs. The supported bandwidth is 100 megabits per second for basic, 650 megabits per second for VPN GW1, 1 gigabit per second for VPN GW2, and 1.25 gigabits per second for VPN GW3. But of course, it's important to remember that your bandwidth connection may actually be limited by your on-premise internet circuit. The basic SKU supports just one tunnel if set up as a policy-based VPN, or 10 when configured as a route-based VPN. The higher SKUs all support 30 route-based site-to-site tunnels. The basic VPN supports 128 concurrent point-to-site tunnels from remote clients using the Secure Socket Tunneling Protocol, or SSTP. The VPN GW1 SKU supports 128 SSTP connections and also up to 250 IKE version 2 or OpenVPN client connections as well. VPN GW2 supports 128 SSTP connections and up to 500 IKE version 2 or OpenVPN client connections. And finally, the VPN GW3 SKU supports 128 SSTP connections and up to 1000 IKE version 2 or OpenVPN client connections. Some organizations decide not to use native Azure services such as ExpressRoute or VPN Gateway, but instead decide to use network virtual appliances or NVAs from third parties. They can be used to create IPsec tunnels between on-premise infrastructure and Azure virtual networks in a similar manner to Azure VPN Gateway, but with some additional features. IPsec with certificate authentication can be used instead of a shared secret, and this is often a security requirement for government and financial services sectors. NVAs typically offer a VPN client with a host of extra features, such as added security, auto connections, and ease of use. Advanced security features can be configured on the NVA, such as web category filtering. They can be application and identity aware, and web anti-malware and threat intelligence feeds are also often integrated. Finally, if an organization already uses a particular technology on-premise and has the expertise supporting infrastructure and processes, then it's often a very natural extension to implement the same technology in the cloud as well. Some of the vendors providing network virtual appliances in Azure include Palo Alto, Cisco, Check Point, Barracuda, and Fortinet. To implement a network virtual appliance in Azure, purchase via the Azure Marketplace, deploy using an ARM template, ARM standing for Azure Resource Manager, install the appliance within the VNet, inside a DMZ subnet. The NVA will be assigned a private IP address, and an associated public IP address. After configuration, create the custom route table, which typically will have a default route to the NVA private IP address. Apply that route table to all the virtual machine subnets. Well, that concludes this lesson on Azure Hybrid Networks. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture.